Welcome to tonight's video. We're going to talk about the geometric series and how to find the sum of a finite geometric series. First of all, let me get the pen. So in order to find the sum of a finite geometric series, you need to know a couple things. Number one, you need to know what the first term is. You need to know what the ratio is. And you need to know the number of terms. So here is the formula to find the sum of a finite geometric series if you know a specific amount of terms, or if you want to find the sum of a finite amount of terms. Remember, you need to write it in summation notation first before you find the sum. Later, we will come up with the derivation for this formula. As far as infinite geometric series go, we will not talk about those yet. We'll talk about those in another unit later on in the semester. So now, looking at the questions here, the first one, given the sequence, is it an arithmetic or geometric? And the answer is, it is a geometric sequence because r is equal to -2. There's a ratio. You're multiplying by -2 from term to term. It says find the sum of the first 6 terms. So to find the sum of the first 6 terms, starting with n equals 1 to 6, of 5 times -2 to the n minus 1. So you want to put the explicit formula equals, and then you find the sum. So it's 5 times -2 to the 6th minus 1. That's the numerator, divided by -2 minus 1. So you'll put that all in your calculator, and when you do here, you get -105. -105. All right, and to put it in your calculator, so to put that in your calculator, you would go 5, and then parentheses, another parenthesis because the ratio is -2, and then to the 6th power, -1, and then you're going to close the parenthesis for the numerator, divided by, and now there's two things you can do. You could type it in all at once, or you could take -2 minus 1 and just get -3. Since it's negative, I'm going to put it in parentheses. Hit enter, and that's where you get -105 from. I know it's off the screen, but it says -105. All right, so that's the sum. Now the second one asks to find what term is 96 in the sequence. So first of all, the ratio, and remember we can find the ratio by dividing the second by the first. So you get -2, and then if you look at the explicit formula, b sub n is equal to 3/2 times -2 to the n minus 1. Well, the last term is 96. And we want to find out what term number it is. So we first multiply by 2/3, and we get 64 equals -2 to the n minus 1. Well, 64 is -2 to the 6th. Then you can drop the base, and you get 6 equals n minus 1, so 7 equals n. So that means that you're going to find the sum of the first 7 terms of, starting with n equals 1 to 7, of 3/2 times -2 to the n minus 1 and that's equal to, and so you'll take negative 3 halves, or sorry, positive 3 halves, and multiply times negative 2 to the 7th minus 1 over negative 2 minus 1. So when you multiply that in your calculator, you should get 63 over 8. Sorry, it's actually 129 over 2. I apologize for that. All right, number 3, the same type of problem. The first term is 4, the ratio is 1/2. So the explicit definition is 4 times 1/2 to the n minus 1. And you want to figure out what term number is 1/8. So you divide by 4 and you get 1/32 equals 1/2 to the n minus 1. 1/32 is 1/2 to the 5th. And then you drop the bases, so 5 equals n minus 1. So 6 is equal to n. So you're trying to find the sum of the first 6 terms, starting with n equals 1 to 6, of 4 to the 1/2, 4 times 1/2 to the n minus 1. And so when you put that in, you're going to put 4 times, and then it's 1/2 to the 6th minus 1 over 1/2 minus 1. And when you type that in your calculator now, you get 63 over 8. Number 5, you want to figure out what term number is 1 over 256. So first of all, a sub n is equal to 1/2 times, and the ratio is 1/2, so 1/2 times 1/2 to the n minus 1. Since they're the same number, you can add the exponents, so 1 plus n minus 1 just gives you 1/2 to the n. And you want to figure out what term number 1 over 256 is. Well, 1 over 256 is 1/2 to the 7th, I believe. Actually, sorry, the 8th. So then n is equal to 8. So you're now finding the sum of the first 8 terms of, starting with n equals 1 to 8, of 1/2 to the n. And so when you do that, the first term is 1/2. Actually, sorry, the first term is 1. No, it's 1/2, sorry. 1/2. And then the ratio is 1/2 to the 8th minus 1 over 1/2 minus 1. And so when you put that in your calculator, you get 255 over 256. All right, so the last question says find the missing terms of the sequence, so 8 and then blank blank 64, such that the first 3 terms form an arithmetic sequence and the last 3 terms form a geometric sequence. So first of all, to form an arithmetic sequence, you would have to have a common difference here, right? So if you look at this as far as putting x and y, x here would equal 8 plus the difference, right? And then that's equal to x. And then for y, y would equal x plus the difference. That's in the arithmetic sequence. For the geometric sequence, and we'll come back to the arithmetic, but for the geometric sequence, for the ratio to go from one term to the next, you get 64 over y equals r, and y over x equals r. Right, that's how you would find the ratio, because the first term is x. So to find the ratio, you divide the previous term, the term by the previous term. So that means if you set these ratios here, you get y squared equals 64x. So we'll come back to that. Now here, notice if it's an arithmetic sequence here, and we get 8 plus the difference equals x, and y equals x plus the difference. If we subtract to get rid of the d here, so if we just eliminate the d, we subtract, we get x minus y equals 8 minus x. So if we solve this for y by moving the x this way, subtracting the 8, and adding the y, so we get y equals 2x minus 8. So now you should notice something. You notice what y equals, so you can take this and substitute it in for y here. So you get 64x equals, 2x minus 8 squared equals 64x. So now we're going to FOIL. So 2x minus 8 squared gives me 4x squared minus 32x plus 64 equals 64x. And then when we solve everything by basically moving the 64x over, we get 4x squared minus 96x plus 64 equals 0. So you can divide everything by 4. Everything's divisible by 4. So you notice you get x squared minus 24x plus 16 equals 0. Now that is not factorable, so we can do the quadratic formula. So we get x equals 24 plus or minus, because it's negative b plus or minus the square root of b squared minus 4ac all over 2a. So when you simplify it, you get 24 plus or minus 16 rad 2 all over 2, which simplifies to 12 plus or minus 8 rad 2. So that is what y is. Or sorry, that's what x is, right? So x can be 12 plus or minus 8 rad 2. So that means y, since we know y is equal to 2x minus 8, so that means y is equal to 2 times 12 plus or minus 8 rad 2 minus 8. So that means y is equal to 24 plus or minus 16 rad 2 minus 8. So that means y is equal to 16 plus 6 or minus 16 rad 2. So when you talk about the sequence here, the first term was 8, then x can be 12 plus 8 rad 2, and then it can be 16 plus 16 rad 2, and then it can be 64, or it can be 8 and then 12 minus 8 rad 2, 16 minus 16 rad 2, and then 64. Those are your terms that would make the first 3 terms an arithmetic sequence and the last 3 terms a geometric sequence. All right, so I hope you enjoyed the video, and next time we will talk about some word problems to apply for the sum of a geometric sequence. All right, have a good evening.